Today we're going to be talking about plate tectonics. Turn to page 8 and title page 8, What is Plate Tectonics? Notes. You have two pages or two papers in front of you. One of them says, What is plate tectonics? And the other says, Plate tectonics vocabulary. We're going to look at the paper that says, What is plate tectonics? Grab your highlighter, and we're going to highlight the important information we need to know. I'm going to go ahead and highlight this definition for plate tectonics. Plate tectonics is the theory that Earth's crust is broken into large, moving pieces called tectonic plates. In our Oreo cookie lab, we learned about the lithosphere. The lithosphere is what is broken up into those tectonic plates. So the crust is broken into large, moving pieces called tectonic plates. The reason these plates move is convection currents in the mantle. So I'm going to highlight convection currents move the plates. When we talk about Earth's crust, that outer layer, there are two types of crust we need to be familiar with. The first one is oceanic. And what we need to remember about oceanic is that it is more dense or heavier. So this is that crust that's found under the ocean. It's younger, it's thinner, and it is more dense. Continental crust is the second type of crust. It's found on land, it's older in age, it's thicker, and it is less dense or lighter. The heavier or lighter of these types of crust has to do with the density of the rock that the crust is made up of. So grab your pen or pencil, and we're actually going to label this diagram that we see down here, okay? So you can see that we have the ocean. Here is our ocean water, so I'm going to label that ocean. This crust right below the ocean, this is our oceanic crust. So I'm going to label this oceanic crust. Okay, that would make this thicker crust here continental crust. So here is land up here. Remember that the oceanic crust is more dense, it's heavier. So that oceanic crust is going to sink down below Earth's surface. That continental crust is a little lighter, so it's just going to stay up top. Now notice below the crust, okay, this is our crust, so this is Earth's crust. Below the crust, we have the mantle. Okay, so we could say that by saying this is our lithosphere and this is our asthenosphere. We talked about this in our Oreo cookie lab. Now notice these arrows that you see in the mantle or the asthenosphere. These are the convection currents that are moving. So I want you to think of like a lava lamp. Okay, we have a heat source at the bottom. That would be the heat source from the center of the Earth. So we can say heat source from the core or the center. And that heat source, that heat is going to be heating up all of this magma that we have in the mantle. Okay, that warm magma is less dense, so it's going to rise up towards the crust. And once it gets away from the heat source, it's going to cool off a little and it's going to sink back down, kind of like a lava lamp. In a lava lamp, you have the substance that's at the bottom, it heats up, it rises to the top, and then it gets away from the heat, and so it cools and it sinks. So over here on the right-hand side, we have the warm magma that rises, it gets closer to the crust, so it cools off and it sinks. Pause if you need more time to record information. We're going to go ahead and glue this little note sheet under our title, and then directly under that, we're going to glue our vocabulary page. So glue both of these on page 8.